Well, welcome to my presentation here on connectivity and the foundational link of the Industrial Internet of Things. My name is Dave McPhail. I'm the President and CEO of MEMX. MEMX is, essentially our tagline is measuring manufacturing excellence. It's exactly what we do. We have a booth here at 2617, so this is not going to be a technical presentation about our products or our technology. If you want to go see that, we've got sales guys down in that booth and they'd be happy to entertain you. So with that, we'll get started. So we're going to cover data streams required to fuel an IoT implementation. So we'll look at some situational awareness in the IoT era. We'll talk about factory of the future and production visibility. We'll move on to what the difference between IoT, and Industry 4.0 is, and what all the fuss is about. We'll talk about IoT, OT convergence. We'll talk about some use cases, some roadblocks to adoption, some specific examples with real numbers so that people get an idea that this is something that can be taken advantage of today. Some additional transformational benefits, summary, and then I'll do a Q&A at the end. So what are the data streams required to fuel an Industrial Internet of Things implementation? So if we look at this graphic here, machines at level 0 and ERP is at level 4. We have a manufacturing execution in between. We have a level 2 distributed control, and we have the actual physical connection. So these are the 5 pieces that are required from an ISA 95 standard perspective. And again, this is all being recorded, so you can get a copy of this online, video-wise. So it'll all be recorded with the PowerPoint presentation as well. So what's the drive towards connectivity? Why does it matter? Well, first of all, higher customer satisfaction is a key foundational point. Lower costs, have competitive agility, and to be able to have ultimately greater productivity, where everybody in the enterprise, from the shop floor, the top floor, everybody's working with the same data set, and then we can extend that data set outside to our trusted partners, our trusted suppliers, and our trusted customers. So I want to talk a little bit about MTConnect. Who here has heard of MTConnect? Awesome. Neil, we got 3 people. So I'm going to just give you a little bit, for those that don't know what MTConnect is, stands for Manufacturing Technology Connect. If I look at the left and the right of this graphic, on the left-hand side I've got a plethora of different manufacturing machine tools. They couldn't be any machine tool making anything. On the right-hand side on your right-hand side, I have applications that require this data in order to create business outcomes. Things like, in our case, we calculate overall equipment effectiveness, but you could do predictive maintenance. There's a bunch of different business use cases. So those applications require data. And before MTConnect, and I've been in this business a long time, almost 20 years, we would have to write a specific driver for each one of these machine tools. And because I wrote them, I wouldn't share them with my competitor. What that did for consumers was it actually raised the cost. It raised the cost because you would have to pay me to write it, and I wasn't going to share it because it was my IP, and on and on and on. So we fast forward a little bit. AMT got together 2006, 2007, I think we talked about it. 2008 was a reality, and funded the development of MTConnect. And so here's what the landscape looks like today, about 9 years later. We have the same tools on the left, we have the same applications on the right, but now we've got a protocol and a universal way to pull that data out so that I can consume it. Neil works for Mazak. His company can produce that data, and you as a customer, for us, it's plug and play. So the barrier to entry is really low, and what does that do? That increases the business outcome. That increases the return on investment, and actually increases the ease of. The other thing it does is it allows you to take advantage of multiple business outcomes with the same data stream. So just to simplify MTConnect for a minute, it's an open source and royalty-free protocol, free to join, free to deploy. It doesn't cost you anything. Think of it as a Bluetooth or USB for manufacturing, sort of like ubiquitous. Doug Woods, the president of AMT, has said a few times that you'll know when MTConnect has made it because nobody will talk about it anymore. Right? Nobody talks about Bluetooth anymore or USB anymore. They've become fixtures in how we operate our businesses and our personal lives. Most newer machine tools, in fact, some machine tool manufacturers like Mazak, example, have an upgrade path that is very long. Windows 95 controls can be upgraded to MTConnect, but also all the new machines also can come with an MTConnect adapter. But for those legacy pieces of equipment, we have to have a hardware adapter that essentially turns the machine into a web server, and I'll have a slide on that. When you think about the 3 things of MTConnect, think about the 3 A's of MTConnect: adapter, agent, and application, in that order. Adapters on the machine, agent is what serves the data to the application. So this is just an example of a hardware device that actually can be put on a legacy machine tool and turn it into a web server. And this is our example of one of our products that we have. We've installed hundreds and hundreds and hundreds of these, and they just work. They just they turn digital data that's locked in the control into MTConnect so that it can be consumed, and again, a business outcome can be created. This is an example of some of those older machines that have been actually brought into what is the 21st century. A lot of these controls on here predate the advent of Ethernet, so there was no physical Ethernet port to plug into. When we look at 3 data streams required to fuel an IoT implementation, we've talked about the connectivity piece from the machine, but we need 2 other ones. We need data from the human capital that operate the equipment, and we need data to and from ERP to enable the factory of the future. So operator data is the human capital data coming directly from the operator through an operator portal. We have business systems data, all the scheduling, all the production routing, all that information comes to the factory floor so the operator can look at it, and we know what job is being run on what machine and what the production schedule looks like and a look-ahead perspective. And then we talked about the machine data, actually pulling the data directly from the machines. So when we have these three systems, when we don't have these 3 systems, we have reactive. We're not reactive, we're not being proactive. So we're reacting to a problem, reacting to another problem, reacting to another problem. We actually can't see those problems before they happen because we don't actually have the data to support it. Whereas when we look at collecting all 3 of these pieces of data and putting them together in one application, now we have proactive data. We can actually see things, we can see trends, we can see when production operations are not actually meeting standard, as an example. And then we know exactly where to go and what to do to fix it. So we look at business systems integration. We have we take the ERP data to and from the ERP system. We bring it into a server. So we track job progress. We can minimize work in progress. We can improve our scheduling. We can improve our on-time delivery to our customer. There's a lot of we can improve our in and out with our suppliers, our trusted suppliers. We can know in advance that products are coming out and products are being required to be heat treated or surface treated or whatever. So the combination of the business systems integration is really important. Because ERP systems are very good at saying, go make this and tell me when you're done. But then somebody on the factory floor has to take that paper router and deal with it and produce that product and then go back and feed it back to ERP. When we connect our business system data with our shop floor data, we do that automatically now. And what that does in ERP is drive things like inventory and procurement directly without physically having to have data. It gets rid of the latency and it gets rid of the inaccuracy. So we talk about how data-driven manufacturing, how it comes alive. Well, first of all, we need evidence-based, time-sensitive, real-time data from the factory. If we don't have that, and from the human capital, if we don't have that, we're shooting in the dark. We have no idea how our factory floor operations are performing. We need to have tied into ERP, so we need to have that data. We need to know what the work order or look-ahead schedule is, because there's this great schedule that's been produced, but what happens if we have machines on the factory floor that are down for maintenance and we don't have another machine that can run that part? Then what do we do? Then we have a problem, we have to solve it. So at least we know that we have that problem coming. If we want to get really elegant, we can do work in progress, raw material tooling, so high value tooling. We can actually use RFID and we can track it through the factory so that we know where it is, and we can actually bring it to a machine to produce that part before that machine is actually set up to run that part, if we know that it's coming. What's the purpose of doing this? Well, everybody wants to drive costs out of their manufacturing operations. Everyone wants to be able to do more with the same level of effort. Productivity and profitability are intrinsically linked to each other. The higher the productivity, the higher the profitability. Process improvement is never a straight line. It's never from point A to point B. There's 3 things in any company that constantly change. There's the equipment, there's the people, and there's the products that the factory makes, or the company makes. Everybody's looking to expand their operations and expand their product line and the ability to produce different products for different verticals. Those 3 things are constantly in flux. And if we're not measuring everything in real time against the machine, against with the person that's operating it, and against a work order, we're going to find it very difficult to improve our operations over time. And then horizontal and vertical integration, as I said earlier, the ability to extend the look-ahead schedule to our trusted suppliers, or the ability to give our customers, hey, we're going to have this part ready next Thursday. If we don't have the transparency and visibility on the factory floor, we're never going to be able to answer that question. So factory of the future, the how. So we're a big proponent of the operator is key. And so being able to give the operator the tools to be part of a solution rather than just simply pointing out that there's a problem is both, it's a culture shift within the company. A lot of people blame operations or operators for poor performance. The reality is, in my experience, having done this for 20 years, I would say 3/4 of the time or more, it's actually out of the operator's hands. It's a maintenance-related issue that the operator's been complaining about for years in some cases. And I have many examples. You can talk to me after. I'll give you examples of why the operators sometimes get ignored. And they're vital to improving the productivity of the factory. Teamwork. If we have one version of the truth, then we all work from the same version of the truth, we're going to make the right decisions. It's not any more complicated than that. And then we vet goals collectively, we set benchmarks, we set goals, and then we raise those goals over time once we've met them. And then, as I said, I've said this before, but we really need to have our ERP system connected to our shop floor in real time bidirectionally. When should we do it? Well, in our case, just using our numbers as an example, on average, we're 10 to 50% productivity increase to our customers. We've done this 150 times. So when I challenge our sales guys to go and talk to our customers, I always say to them, make sure that the customer understands the value equation and the value that they'll lose by not doing something. In other words, by putting off a decision and calculate that for them so they can actually see those numbers. And we'll go through a couple of examples quickly. Again, using a proven solution and with a culture change, the risk of a project failure is drastically minimized. And there's a lot of money locked and left on the factory floor every day. Most companies think they're 65% efficient. We've done this 150 plus times. The actual number is sub 35. And it's a shocking number, but it's the truth. I've got reams and reams of data to prove this. What does production visibility look like on the factory floor? Well, it looks like this. This might look familiar to you, Neil, this picture. So this is an example of a operation within a factory where the operator is actually coming up to see how the cell's doing, how the physical equipment is performing. Production data captured in real time, and it's obviously sent to management, but it's also available to operations. So again, one version of the truth, everybody has it. And then operational awareness, having the operators have the ability to understand what they do and how their interaction with the equipment increases or doesn't increase productivity is extremely important. You start to foster that competition between cells, two cells making similar parts. Nobody wants to be the person with the lowest productivity number. Even though probably not going to get fired for that, but nobody wants to be last. Everybody wants to be part of a winning team. Again, Gemba boards and and-on screens can be powered directly without having to actually aggregate data in Excel and then be able to have to print this stuff out and pop it up. All this data can come out. It can actually be done electronically. We have several customers that will use Gemba boards and and-on screens directly on the factory floor, and they don't actually print out or aggregate in Excel any more data because it's already done automatically. Common and objective data right across the entire factory, that's important. Not just key machines, but every particular piece of equipment that's manufacturing high-value products should be monitored because bottlenecks move around, as I said earlier, because of the three constraints. 6 to 10% efficiency on average just by putting and-on screens on the factory floor is what we've seen. So just by giving the operational management team the ability to see where they are right now on that particular job is an automatic 6 to 10% increase. At 9.5 times out of 10, that more than pays for the project itself. This is one of our customers. It's almost like the cockpit of a jet, I guess, if you will. It's got screens everywhere, and this is what this operational management team uses to monitor their entire. They've got 30 machines, and this is what they use. The one on the left, again, you might recognize that one. One of our customers has 12 or 14 of these all around the factory floor, and these big and-on screens. What does situational awareness look like in the IoT era? Well, this is an example of it. This might be another example. Here's another example. Yet another example. What's all the fuss about with IoT and Industry 4.0? Well, I like this particular stat because it talks about global GDP. It doesn't talk about just GDP, America's GDP, or Europe's GDP, or North America GDP, or South America GDP. It talks about global GDP, and it's done by Accenture. I don't know what that number is. Could be 8 trillion, could be 4 trillion, could be 22 trillion. I don't really know because there's a different stat every week. Somebody crunching numbers. The reality is, though, is it's a big number. It's a real big number, a real big impact to GDP when this technology is harnessed and put through the enterprise. So a little bit of history about Industry 4.0. It's the fourth industrial revolution. We're actually a little bit beyond where we're talking about convergence of IT, IoT, and Industry 4.0 into one concept, which I'll get to, I think, on this slide, or maybe the next slide. So industrial Internet of Things, manufacturers take huge advantage of IoT technology. Competitive advantage comes from the machine-to-machine connectivity and actually having the data. And IoT applications connect, analyze streams of manufacturing data in real time. And there they are again. MTConnect, FANUC Focus, OPC, and other protocols, or a hardware adapter. Then we have the data from the ERP system, and again, we have data from the operator portal. This all fits nicely into the construct of industrial Internet of Things. And again, it's only one business use case. There are many business use cases with IoT. I don't have enough time to go into them all, and I don't think we thought of them all yet. So here's some more examples of IoT in manufacturing. We're talking about OEE metrics, financial OEE metrics, high-value asset tracking with RFID, OSHA work envelope compliance. Again, other examples of business use cases. We concentrate, MEMX concentrates on overall equipment effectiveness and financial overall equipment effectiveness. Where are we in the connected manufacturing revolution? Well, we started in 1960 all the way through to 2017, micro PCs, we went to the internet. Really where we are right now is what we call the data-driven manufacturing, connected manufacturing model. And it really is a technological shift. 9 out of 10 companies don't monitor the assets on their factory floor in real time. So there really is a huge opportunity to take advantage of this technology, harness it, and create a very compelling business outcome. What we call this universal machine connectivity. I want to talk a little bit about how you can visualize. One of the questions that I get asked a lot is from senior management in companies is, I've been told I got to do this IoT thing, but I have no idea where to start. I don't understand. I'm hearing different stats. I'm reading different things about industrial Internet of Things or IoT or Industry 4.0. So I want to sort of try and dispel this down into a very simple concept. So we've got IoT was coined by MIT in 1999-ish. We have Industry 4.0 from the German government circa 2010. I tried to find a stat on this one. Cisco said they coined it, GE said they coined it. I don't really care actually, but the point is we have these three concepts that are kind of competing for people's attention. So we think there's been a convergence, or we would like you to think that there's been a convergence of these three ideas into one common concept we call data-driven manufacturing, where we have consolidated reporting, big data and analytics. We have corporate dashboards, all driven by real-time data. And this whole concept we call data-driven manufacturing. And when you explain it that way to people that previously were trying to understand the concept of industrial Internet of Things or Industry 4.0, they get it. Oh yeah, so IoT or Industry 4.0 or IIoT is all really data-driven manufacturing. Yeah, it's one business use case. I want to talk about the reality versus myth in data-driven manufacturing. So the myth is it's a theoretical construct with no practical application, an unquantifiable capital expenditure with no known return on investment, a highly technical deployment strategy that never gets to the finish line, and that it's a magic bullet or a solver of every single problem that manufacturers face. Those are all myths. What's the reality though? This technology has been both disruptive and transformative, but both in a good way. It's a known and quantifiable payback. In our case, we tell our customers approximately 300% internal return rate of capital or a 4-month payback. That's practical and proven to be of major benefit in eradicating productivity gaps. Presently generating, I said, 300% internal return rate and it's available today. Those are reality. So we have myths and we have reality with respect to data-driven manufacturing. Talk a little bit about IT versus OT convergence. This is absolutely going to have to happen because right now IT and OT, they sort of work at opposite ends of the spectrum, and so what's IT care about? Well, IT cares about, they care about the physical risk of the factory floor and actually enabling the ability to connect all these assets on the factory floor. It's their domain of responsibility. There's a stat here from Gardner, but they're worried about outdated or custom systems. And what's OT care about? Well, OT just wants to get the job done. OT wants to increase the productivity of the factory. In order to do that, they need a network. When they need a network, they have to go to IT. So IT is usually the first answer out of IT's mouth is no. I mean, I've seen it. I've actually been in meetings where IT and OT, I almost feel like I have to get the referee's shirt out and the whistle. It looks like there might be a fight breaking out. But OT also cares about physical risk and safety. Nobody wants to expose themselves to a virus or a potential harmful impact. Obviously, they care about productivity and quality control, care about data leaks, and they have concerns working with IT. So in order to overcome this, what does that mean? How do we do this? Well, what we really need is, when we look at the different data streams that IT cares about, well, IT cares about the server, the applications, obviously the ERP system, SQL Server historian, all the applications and the networks. Well, what does IT care about? Or sorry, what does OT care about? Well, they care about all this other stuff. They care about, in this case, if we have a machine shop, we care about the DNC system to transfer programs. We also care about having our dashboards and our and-on screens and everything else that goes along with it. We care about applications, being able to connect our machines, and we care about all the applications at the top to be able to enable these business outcomes and take the tools or the promise of these tools and actually drive the business value through the enterprise. So what we believe has to happen here is a convergence of these two camps into working together, and there's a really good example of how that can be done in that box over there called a smart box. And Neil's going to get to that, so I'm not going to steal your thunder. I'm just going to say it's a really good example of how we can converge these two camps to work together because both of them get what they want. Identifying and authenticating devices within the system, encrypting all communications between these devices. This is how these two camps can work together. There's a few more bullet points here. Again, Neil will go into a lot more detail, I'm sure. Areas to explore for benefits. In our case, we deal with overall equipment effectiveness, as I said. Here's some critical business challenges that we hear from our customers. Data collection accuracy, rising business costs, reducing operating costs, visibility. I want to know what's going on. I want to see it on my smartphone. I want to see it on a tablet. I want to have a proactive email alert about when things are not working correctly. And obviously, continuous improvement initiatives like TPM and Lean are extremely important critical business challenges for our customers and others. Why does OE matter in the IoT era? Well, first of all, it's one of the most important metrics in manufacturing. For the first time, we can actually distill the productivity of a factory full of equipment down into a number, and we can measure it and benchmark it against world class. Who here is familiar with OEE? Excellent. World class 85% is entirely achievable with this automated approach, and we have several customers that have gone to 85%, in some cases slightly above that. Availability times quality times performance is the number, is the actual statistic, and we really see it as the gold standard for manufacturing. A lot of companies are tracking it manually now. There's now a way to do this automatically. What drives the desire for OE? Well, first of all, we get rid of subjective data collection and replace it with objective data collection. We shine a light on dark assets, so we actually can see the entire factory full of equipment from one dashboard or multiple views of the same dashboard. And the biggest one, I think, is we reveal a hidden factory, because if you buy the stat that I gave you earlier that said most manufacturers think they're 65% and they're actually 35%, if we get them to 65 to 70%, that's like finding an additional entire factory full of capacity. What are some of the roadblocks and what to be on the lookout for? So I always challenge our sales guys with this particular graphic. I always say to the customer, I said, when we first went to market about 8 years ago, we spent an inordinate amount of time on the how, a little bit less on the what, a little bit less on the when, and the why was the thing we talked about the least when we first went to market. And the problem with that is the why is what gets a project funded. The why is what the CXOs of the companies will actually sign the capital appropriation request. So when we go to market now, what we do is we spend a lot more time on the why. We make sure that we work with the customer to understand what that why means in terms of dollars and cents, so that the when, the what, and the how are, although still very important, they're not near as important as the why. The why is the most important piece, because otherwise these projects don't get funded. So the issues considered: the why, focus on the business case, focus on the competitive advantage. Culture of the company is a big one. We find that this, as I said earlier, this is transformative and disruptive technology. Probably the culture is the number one thing. It has to be a culture of inclusiveness where this data is used by the entire team to affect change for everybody. It's not to point fingers at why production always said it was operations' fault and operations always said it was production's fault. The reality is it doesn't matter. Right? If we're all on the same team, we got one version of the truth. Now we can work towards a common goal, which is increasing our productivity and upping our customer satisfaction. And we can do that because we have one version of the truth now. And then too busy with tyranny of the immediate. We get this objection a lot. Nobody has time. There's nobody in the company that can use the data to affect change. Well, if we don't have, there's no impetus to start, we're not going to get to the finish line, or we're not going to get anywhere near implemented with this technology or be able to harness the benefits that it promises. Fear, uncertainty, and doubt. So fear of failure, fear of data and system security, fear of the unknown, and fear of change. These are huge demotivating factors to adopt data-driven manufacturing. Uncertainty, uncertain of the path forward and uncertain of the quantifiable results. I hear this a lot. You don't understand my business. We're different. And then when we sit down and we talk to the customers and we listen to what they have to say, usually the conversation turns around to, I think this could work for me, like it's worked for some of the other customers that we've worked with. So everybody wants to feel unique and different. And then the doubt is the doubt about the promised business outcome and, again, the required cultural change. I doubt, some customers will doubt in the beginning that they actually have the ability to change the culture of the company, and that's foundational to the success of a type of project like this. Whether it's measuring OEE or doing some other business outcome, to be able to trust the data, to be able to use the data effectively as a group and as a team, the culture of the company is absolutely 100% foundational to success. So when we call FUD, fear, uncertainty, and doubt, we call it the analysis paralysis problem. So if we have the doubt plus the uncertainty and plus the fear, what do we end up with? We end up with inaction. We end up with endless delays. We end up with lost opportunity costs. Because if the return on investment, if you believe the return on investment that I said of a 4-month payback, 300% internal return rate of capital, and we wait a year to embark on one of these projects, we could have had that money back on our balance sheet 3 times. We could have redeployed that capital 3 times. Specific examples of return on investment with real numbers. So this is, if the factory on the left is what we see typically when we start, the productive times at the bottom, and then all of the other losses add up to this, about the 60+% of time that's right now non-productive. The desired outcome, though, is to try and get that world-class number, or production time up to 85%, and minimize all of those other 6 big losses. To be able to bring those down to in line where, I mean, we're never going to get to 100% productivity every single time, but we can get a lot closer than 35 or 40 to world standard at 85. This is where it comes from. There's no magic bullet. There's no one thing that you can do in your factory that's going to drastically increase the productivity. They're all small little things, like operator productivity, reducing downtime, minimizing rejects, on and on and on, value stream collection and analysis, fueling your continuous improvement program with this data and rinse and repeat. So go back and remove a constraint, another one appears, go back and remove that one. All this adds up to somewhere between 10 to 50% productivity increase, just by little small things. Example 1, so we have 10 machines, 5 days a week, 8 hours a day, $85 an hour loaded labor cost. We're going to focus on 5 of those machines with a hardware connection and 5 of them with a software connection. We're going to talk about a small incremental 3 and 2 minute. So we're going to get 3 minutes from reducing the downtime, and we're going to pick up 2 minutes of productivity because we're going to increase the visibility, which translates into about an 8% increase in OE, a very nominal, conservative number. What does that do for this, if this company was to embark down this path for, say, a small job shop, what would that do to their bottom line? I'll fast forward to the right. That's approximately a 200% internal return rate, about $142,000 saved over 12 months, and over the 3-year period, about $450,000 net to that company on just a 10-machine implementation. Again, this is empirical math. There's no new math in this calculation. It's actual math. Medium-sized manufacturer, same. This time we're going to look at 30 machines, 5 days a week. We're going to look at 2 shifts instead of 1. We're going to look at half the machines hardware, half of them software. We're going to look at the same incremental 8%, 3 minutes and 2 minutes per hour per machine incremental increase, or 8% OEE. This company is greater than a 400% internal return rate, approximately $850,000 for a $150,000 spend, and about $2.5 million over the 3-year span. We have customers that have done this. We have customers that have actually exceeded these numbers. Some of the additional transformational benefits, I'm going to breeze through this. So impactful continuous improvement. Typically what happens in continuous improvement without real-time data is we have a Kaizen event, we spend a day to a day and a half collecting some data, we analyze that data, we make a process improvement change, we collect more data, and we see whether that was a positive, neutral, or negative, was it accretive or destructive to the actual baseline productivity. We don't have to do that anymore. We don't have to collect the data on the day or day and a half in the front, nor the half day at the end. All we have to do is launch continuous improvement programs based on trends that we see with the real-time data and the historical data that we've already collected. Customer success, these are just some examples, and again, I'm running out of time here. I'll leave a few minutes for Q&A. Again, these are specific, not specific to any one particular customer, just a keiretsu of benefits from customers that we've worked with. And in summary, this is being applied successfully today. This isn't, again, a theoretical construct. Benefits are extremely compelling if you buy into the math that I just went through. The last meter problem has been solved. We can connect all of the legacy equipment that exists. About 70% of the equipment on factory floors today is what is deemed the legacy equipment, where the only way we're going to get the data out of that equipment is actually plug in a hardware device, and we chose to develop an MTConnect capable hardware device. And then the why should always be talked about, and internet security should always be paramount. We shouldn't just open up the network and see what happens. And with that, I'll take some questions. Mark, you had your hand up first.
Talking about to the profitability of specific jobs and making good choices and decisions based on the knowledge of how that affects your bottom line. And I think you ought to talk a little bit more about that, if you would, please.
Yeah, so financial OE is essentially calculating the income from operations contribution, asset by asset, hour by hour, based on the product mix that's running through the factory at a given point in time. And if we have that information and we can calculate the IFO contribution, asset by asset, hour by hour, when we're running that job again, we can look at where we benchmarked it before, and we can see the delta of the money that we're leaving on the table, because every single machine will contribute an income from operations contribution depending on what value of product that it's making. And so what financial OE does is it takes that, quantifies that IFO contribution, and so that the traditional scorecard in manufacturing is an income statement that comes 3 weeks after the end of the month. And now we have the ability to back that up and say, if we're having a bad day on Monday at 11 o'clock in the morning, we know exactly where we're not going to make our numbers. We're not going to contribute X IFO by 3 o'clock or 4 o'clock, whatever the shift ends. We can actually fix it. And because we know what that number is, and we have 5 or 6 things that are kind of going sideways all at once, we're going to pick, if I run that business, we're picking the one that's going to make the biggest IFO contribution immediately. We'll work on the next, the more important one, and all the way down the line until we get to the least important one. You're going to pick up more money. Once that hour's gone, it's gone. You'll never get the money back that machine could generate in that hour, because you can work another hour. Sure, you'll be able, but that's another hour. You've lost another hour of capacity utilization that you'll never get back. It's only 168 hours to be able to produce in a week, if I did the math right, I think. And if you're not producing at optimum efficiency within those 168 hours, you're not actually making the most money. It's lost opportunity cost.